Okay, students, so this is a calculator aid that will be useful in Unit 3. Or when you're talking about hypothesis testing for a single mean and also a confidence interval for a single mean. So we're going to work with the situation where we're testing and trying to estimate mu, the population mean, when sigma, the population standard deviation, is known, just using our 83 or 84 pluses. So here I have a base model 83 plus, which is kind of dusty, but what you want to do for a hypothesis test is you want to turn it on. Of course, let me get out of that menu so that you get the normal on screen. It's just the blank screen. You want to go to your STAT button, and then you want to go over to test, and because we have the assumption that sigma is known, we are going to do a z-test, and it's one sample. Now you have an input, and you can select data if you had it, but we don't. We have statistics, so we want to make sure that's highlighted. Stats is highlighted. Mu naught is the mean that they were claiming in this example, which is about assembly time. They were assuming 38, so you want to enter your mu naught. You want to enter your sigma, which if I look through the paragraph, I see that sigma is 1.2. You want to enter your x bar, which again, if I look through the paragraph, my x bar in this example is 37.5. You want to enter your n, so they had a random sample in this particular example of 47. And then it says m, or mu, and it has all these different symbols, so you want to pick the symbol that matches your alternative hypothesis. In this particular example, it's a less than symbol, so make sure that's selected now. Go to calculate, and it's going to bring up a p-value, and with the p-value method, all you have to do is write down that p-value that it tells you, and that's all you need from your calculator, and you can put that away then. Over here I've prepped for a 89 titanium example, so I'll leave that there. Once you do that, you know the rest. You just have to compare it to alpha, which, what was our alpha in this one? 0.01. Alpha is less than 0.01, so of course you would reject H naught, and then you would write your conclusion, blah, 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 blah. Based on the evidence, the mean assembly time is significantly reduced, and so on and so on. You would write a nice intelligent sentence. I'm not going to do it all for you because the purpose of this video is just to show you how to work your calculator. So let's pop down and let's assume that we wanted to perform a 99% confident interval for this problem, or for any problem where you know sigma. What you want to do is go back into your stat menu. You want to go over to the test screen, and then you want to scroll down to not z-test, but you want z-interval. Okay, so select z-interval. Again, we're using statistics because that's what we have. We don't have raw data. Check to make sure that your sigma and your x bar and your n are all entered in. And then your C level means your confidence level. We want a 99%, so I need to change this to 0.99 for 99% confidence level. Hit calculate. Immediately you're brought up the interval 37.049 to 37.951. And then you can just go straight to your interpretation. Based on the evidence, we're 99% confident that the true mean assembly time lies in the interval 37.049 to 37.951 hours, and you're done. This calculator really can make hypothesis testing and confidence intervals very easy for you if you have the correct assumptions. So be very careful that you're using a z-test and a z-interval when appropriate. If you use the wrong one, you're going to get the whole problem wrong. Okay? So be careful on that.